Hello everyone. In this lecture, we will discuss on Brayton cycle. The Brayton cycle is applicable to gas turbine plants. So, here we measure the performance of the Brayton cycle. The performance of the Brayton cycle is measured in terms of efficiency. So, to calculate the efficiency, we use the general expression, that is efficiency is equal to 1 minus Q2 by Q1, and Q2 is the heat rejection and Q1 is the heat addition. So before using the expression of efficiency, let's see the PV and TS diagram. So here in PV and TS diagram, we see here there are 4 processes: 1 to 2, 2 to 3, 3 to 4 and 4 to 1. So 1 to 2 process is named as reversible adiabatic compression process. 2 to 3 constant pressure heat addition process. So here the pressure is constant. So 3 to 4 reversible adiabatic expansion process, and 4 to 1 it is constant pressure heat rejection process. So see here the pressure is constant. So now we express the Q1. So Q1 is equal to mCp, that is del T. So del T is what? Change in temperature, and as heat is added, the temperature is changed, that is we consider T3 minus T2. So here you can see that is T3 minus T2. Similarly for Q2, that is mCp del T. So del T is again change in temperature, as heat is rejected, so temperature is changed. So that change in temperature is what? That is T4 minus T1. So substitute the value of Q1 and Q2 in the expression of efficiency, and it becomes 1 minus T4 minus T1 by T3 minus T2. So now we consider the process 1 to 2. So for process 1 to 2, that is a reversible adiabatic compression process. So it is an adiabatic process. So we can use the relation Tp to the power 1 minus gamma by gamma equal to constant, and Tv to the power gamma minus 1 equal to constant. So these are the equations we can use for the adiabatic process. So see here, first we consider Tp to the power 1 minus gamma by gamma equal to constant. So by considering this for 1 to 2 process, we can say T1 P1 to the power 1 minus gamma by gamma equal to T2 P2 to the power 1 minus gamma by gamma. So just rearrange it. So T2 by T1 equal to P1 by P2 to the power 1 minus gamma by gamma. So if I take P2 to the numerator and P1 to the denominator, so this changes to gamma minus 1 by gamma. So next we consider Tv to the power gamma minus 1 equal to constant, another adiabatic equation. So this is T1 V1 to the power gamma minus 1 equal to T2 V2 to the power gamma minus 1. So we can say T1 by T2 equal to V2 by V1. So see, we can say that compression ratio for the reversible adiabatic compression process as V1 by V2. So this is the maximum volume and this is the minimum volume. So by considering that, we can say the compression ratio Rk is equal to V1 by V2. So it is V2 by V1. So we can say that is equal to 1 by Rk to the power gamma minus 1. Similarly, for process 3 to 4, this is again a adiabatic process, reversible adiabatic expansion process. So as it is the adiabatic process, so here we use the relation, that is Tp to the power 1 minus gamma by gamma equal to constant. So we can say T3 P3 to the power 1 minus gamma by gamma equal to T4 P4 to the power 1 minus gamma by gamma. So just rearrange it. T3 by T4 equal to P4 by P3 to the power 1 minus gamma by gamma. So take P3 to the numerator and P4 to the denominator. So by considering that, we get the expression, that is T3 by T4 is equal to P3 by P4 to the power gamma minus 1 by gamma. So we know that 2 to 3 process and 4 to 1 process are the constant pressure process. So we can say P2 is equal to P3 and P4 is equal to P1. So in place of P3 we substitute P2, and in place of P4 we substitute P1. So now we consider this as the equation 1 and this as the equation 2. Just equate these two equations 1 and 2. So after equating, we get T2 by T1 is equal to T3 by T4. So just rearrange it. T4 by T1 equal to T3 by T2. So just consider minus 1 to the both hand side. So then that is T4 by T1 minus 1 equal to T3 by T2 minus 1. So here we consider T4 minus T1 by T1 is equal to T3 minus T2 by T2. Or we can say T4 minus T1 by T3 minus T2 equal to T1 by T2. We know that in the previous equation, that is equation 1 and 2, T1 by T2, T1 by T2 is equal to V2 by V1, or you can say equal to 1 by Rk to the power gamma minus 1, or this is T2 by T1 equal to P2 by P1 to the power gamma minus 1 by gamma. So we can use those values here in place of T1 by T2. So we know that the expression of efficiency as 1 minus T4 minus T1 by T3 minus T2. So in place of T4 minus T1 by T3 minus T2, we substitute T1 by T2. So T1 by T2 is replaced as P1 by P2 to the power gamma minus 1 by gamma. So this P1 by P2 considered to be, that is 1 by Rp, because Rp is equal to P2 by P1. So in place of P1 by P2, we consider 1 by Rp to the power gamma minus 1 by gamma. But this T1 by T2 is also considered to be T1 by T2 is also considered to be 1 by Rk to the power gamma minus 1. So we substitute this value 1 by Rk to the power gamma minus 1 in place of T1 by T2. So the efficiency of Brayton can be considered as 1 minus 1 by Rp to the power gamma minus 1 by gamma. Also it is considered as 1 minus 1 by Rk to the power gamma minus 1. So the efficiency of Brayton is represented in form of pressure ratio as well as in form of compression ratio. Thank you.